Today we have Justan Mann from the Illinois Department of Transportation. Justan has over 27 years of experience working in the transportation industry, and he began his career working in heavy construction of highways, heavy highway construction. He has a master in civil engineering from Southern Illinois University at Carbondale. He joined the Illinois Department of Transportation in 1998. Since then, Justin has held various positions within IDOT and currently is serving as the engineer of construction operations. So let's please welcome Justin.
Thanks. So today I am going to give a presentation, and this presentation is going to provide an overview and highlights of construction at the Illinois Department of Transportation. Specifically, I'm going to provide an overview of IDOT with a focus on our construction office. Secondly, I will highlight some construction contracts that we have underway so that you all can get a feel for what we actually build. And then lastly, I'm going to discuss the department's e-construction initiative so that you can see some of the process improvements we're making in an attempt to take advantage of new technology. So the mission of the Illinois Department of Transportation is to design, build, operate, and maintain a world-class transportation system that provides safe, efficient movement of people and goods to support the state's national and world competitiveness. It's also to make sure that our transportation system is safe. Our mission is also to increase the quality of life of our citizens and visitors by reducing congestion and increasing their mobility. And we do all of this while demonstrating a respect for the environment. In simple terms, what makes a great transportation system great is its ability to connect users from their origins to their destinations. We don't just have a transportation system to have a lot of lane miles and a lot of bridges. We have a transportation system to make sure people can efficiently connect from point A to point B, regardless of where those points might be. So the department is led by a secretary who is appointed by the governor. We call it the Secretary of Transportation. The department was reorganized by our current secretary to consist of 9 offices. These offices include the Office of Highways Project Implementation. That's where I work. That's the office that I'm in, as well as IDOT's Highway Construction. That's where we're housed. Another office is the Office of Intermodal Project Implementation. They deal with railroads, airports, other modes of transportation. The Office of Planning and Programming. They deal with helping develop the size of our program. How much money do we have to spend on what we can build? We have an Office of Communications. We have an Office of Legislative Affairs that works with the legislator. We have an Office of Finance and Administration, an Office of Business and Workforce Diversity, an Office of Chief Counsel, that's where we house our legal staff, as well as an Office of Internal Audits to do checks and balances on us to make sure we're doing things correctly. I'm going to focus on the Office of Highways Project Implementation because that's the purpose of this talk, is with construction. So the Office of Highways Project Implementation is organized into 9 districts. These districts are distributed statewide, as well as 7 central bureaus. All of the central bureaus are located in Springfield, Illinois. District 1 is located up in the Chicagoland region. District 9 is the southern tip of the state. For the people that are here in this room today, you're in Rantoul, you're in District 5. So that's how our districts are organized. The 7 central bureaus include the Bureau of Construction, again where I work, the Bureau of Bridges and Structures, the Bureau of Design and Environment, the Bureau of Land Acquisition, the Bureau of Materials, the Bureau of Operations, and then the Bureau of Safety, Programs, and Engineering. These 7 central bureaus work with our counterparts in each of the 9 districts, again, to design, build, operate, and maintain the highway infrastructure that the department has. In case you just some kind of fun facts, the state highway system that I'm referring to consists of about 16,000 centerline miles or 46,000 lane miles. That's what we have on our state system out there, not including the locals. We have about 7,800 bridges and over those 7,800 bridges, that includes about 84 million square feet of bridge deck. So we have a pretty large system that we have to design, build, operate, and maintain. We do all of this with about $2 billion a year. Now this varies from year to year. It's not necessarily a real stable number, but historically, if you were to look at it over time, it's been about $2 billion a year. That might sound like a lot of money, but people are typically surprised to learn that this revenue that we use to maintain our system has really been this pretty flat increase, just a little bit since the 1990s. How many people in this room, other than myself, were alive in the 1990s, in the early 1990s? So just a few. So I trust that you all realize that that since the early 1990s, we've added to the size of our infrastructure. Our cost to design, build, operate, and maintain this infrastructure has increased exponentially. So it's a struggle sometimes to fulfill that mission of providing that world-class transportation system. So we have to be smart about how we use our limited resources. Ways that we can do this is by not necessarily always fixing the worst first. Sometimes you'll see us working on some projects that don't seem to be in as poor of shape or as bad a shape as another piece of our infrastructure. But we do that because if we can implement preservation treatments at the right time, we can reduce our maintenance cost, therefore using the limited amount of funds that we have be more wise with the use of those funds. Obviously, though, we also have to try to find new funding sources. The 1990s funding levels won't work forever. We're going to figure something out, and so we're constantly trying to do that. We also have to continually look for ways to make our system more efficient. It's hoped that the developments in technology, specifically with autonomous vehicles and connected infrastructure, will help us get more capacity with our existing lane miles. In the past, the most common method to increase your highway capacity was to add lanes or add to the size of your footprint. In the future, it's believed that these connected vehicles and connected infrastructure is going to help us get more throughput on the existing footprint that we have, since the cars are smart and they can kind of talk to each other. Therefore, we may not necessarily have to keep expanding the system like we have done in the past. But anyway, you guys are thinking, or you all in this room are thinking, this is a long way from construction. So let me get back on topic of actual just construction stuff. The best way to summarize construction is we build projects. The construction section of the department is responsible for projects once they're included on a letting. We call that, once we include contracts on a letting and get them awarded to a contractor, we take over responsibility for them, and then we maintain that responsibility until the contract work is complete and we've accepted the work. At that point, we then hand the work. We hand the torch to our operations section of the department that operates the facilities that we've built. Our typical, let me back up here just a minute. Our district, so remember before I talked about how we have 9 districts and then 7 central bureaus? Our district construction staff is responsible for the day-to-day contract administration. The department staffing for a contract will typically include construction inspectors. These inspectors monitor the contractor's work activity to ensure the work is in compliance with the contract. They conduct field tests on materials to ensure that the materials meet the contract requirements. They document their monitoring and testing activities to make so that we have records of everything that we've done. And they're also responsible for measuring and recording quantities of work that has been completed. The number of inspectors that you'll see on a construction contract will depend on the size of the contract. Small contracts might just have the RE, I'm going to get to the resident engineer in just a minute, but might just have one person, 1 or 2 people on them. Large contracts might have in the 10s or 20s or 30s of inspectors. So after the inspectors, I'm going through these kind of in the order in the order of hierarchy. The next level is our resident engineers or our resident technicians. Each contract will have a resident. A resident may be responsible, but a resident may have more than one contract. So a resident might be responsible for multiple contracts at any given time. There is no single more important position in the Office of Highways Project Implementation than a resident engineer, or a resident technician. Residents represent our office in dealings with the contractor, in dealings with cooperating government agencies, for example, local cities and villages, the Federal Highway Administration. They also represent our office with the traveling public and the taxpayer on a daily basis. On a construction contract, the resident engineer is the face of the department. The duties of a resident typically include supervising their assigned inspectors, monitoring the work, and assisting these inspectors as needed. The residents also have to insist on a high standard of work in accordance with the contract requirements, while recognizing that the project is custom built. So they have to make sure the contractors are building what they're supposed to be building us, but they also have to realize that changes are going to happen, and they have to work through those changes to ensure we administer stuff in the most economically and timely manner possible. Residents have to monitor the contractor's progress and professionally communicate their concerns to the contractors. These can be a lot of tough conversations. Oftentimes things don't go well in construction, or you hit road bumps. When everything's going smooth, everything's rosy. When something starts to go south, tensions can get high. There's a lot of money involved with heavy highway construction. So the resident has a difficult challenge to keep their professionalism and communicate any concerns that they have to the contractors to keep our contracts on task. Residents have to anticipate problems and then solve them before they result in costly and timely delays. Residents have to pay prompt, sympathetic attention to the problems brought forth by the public. At the end of the day, we are the public's customer. We're building stuff for their use. We're connecting those origins and destinations. Customer's always right, so we have to treat them with their due respect. And residents are also responsible for preparing and submitting progress payments for completed work. I could go on and on about the requirements or the duties that a resident engineer or a resident technician have to perform, but you all get the task. This is a very busy position and a very important position. Then as you climb the ladder, above the residents, we have what we call typically supervising field engineers. Supervising field engineers supervise their assigned residents, they monitor the residents' work, and then they provide assistance to the residents as needed. This assistance often involves resolving conflicts, approving changes that have arisen, and interpreting the specifications. After the supervising field engineer, or right above the supervising field engineer, we'll have what we call a district construction engineer. The district construction engineer heads the district's construction section, and they are charged with administering all construction activities of the district in accordance with the specifications and department policies. And then lastly, as far as in the realm of construction, above the district construction engineer, we have a project implementation engineer in all of the districts. The project implementation engineer supervises the construction engineer and the materials engineer, and they are ultimately responsible for all construction and materials sections of the district. Next, after we move out of the district and we come back to the Central Bureau of Construction, which is located in Springfield, again where I work, the Central Bureau of Construction responsibilities include pre-qualifying contractors to bid on our contracts. So the way our contracts work is we have what's called a letting. We advertise contracts on a letting or solicit bids via this letting terminology. And we don't just let anybody bid on the projects. We pre-qualify them to make sure we have a level of comfort that when we enter into a contract with these people, if they were the successful low bidder, that they have the capacity to actually do the work. Nobody wants to start a job, get in the middle of it, and then find out our contractors, for whatever reason, aren't able to complete it. So we pre-qualify the contractors to bid. After the bids, we validate that the low bid contractor actually has the financial capacity to perform the work that they were the successful bidder on. We have to do. You might think, why do we do this if you've already approved them to bid? Some contractor might send in a bunch of low bids and they might get 15 contracts. So then we have to go back and say, okay, does this person really have the financial capacity to do 15 contracts or not? So that's part of what that group does. The Central Bureau of Construction also provides general construction or general supervision over all of the contracts. We have an engineering staff in the Central Bureau of Construction that does this, and so we provide this general supervision over all contracts that are included on the state letting. These include both state contracts where we're building infrastructure on the state system, as well as state let local contracts where for some reason a local agency is building an improvement but they've put the contract on our letting. We do both of those. From time to time, and we have to provide this oversight just like the districts do from the time the contract is awarded to a contractor until all of the work is complete and accepted. The Central Bureau of Construction is also involved with processing all contract changes that are submitted by the districts. So something arises in the field that necessitates a change, the Central Bureau of Construction processes those changes, looks at some of those changes depending on the nature of it, and then helps process them through. The Central Bureau of Construction also processes all progress payments that are submitted by the district. So all payments for all of the construction work that you see across the state in our system flow through our office to the comptroller to ultimately get the contractors paid for the work they performed. Central Bureau of Construction assists with the resolution of construction problems and disputes as needed. We are responsible for developing uniform construction policies, practices, and specifications, and we do this in cooperation with the districts, with the other central bureaus, and with our industry partners. And then the Central Bureau of Construction also provides training to help ensure that the specifications and policies are administered consistently statewide. A contractor that's working in District 3 or 4 should expect us to interpret policies and administer specifications as the same as we would say in District 5. So that kind of brings me to the end of an overview of the department. I know that's all real exciting stuff. So now I'm going to roll into an example project and actually show you all what it is that we actually build, or typical stuff that we build. So this project is oftentimes referred to as the Circle Interchange, and it's up in District 1, the Chicagoland region. It's also the formal name of this interchange is the Jane Byrne Interchange. The Jane Byrne Interchange is located in the heart of Chicago, and it connects I-90-94 to the north with the Congress Parkway to the east, the Dan Ryan I-90-94 to the south, and then the Eisenhower Expressway or I-290 to the west. The Jane Byrne Interchange, oops, sorry, let me back up there. The Jane Byrne Interchange was built in the 1950s and the 1960s as part of the interstate highway system, and this interchange is critical to the nation's transportation system, particularly for freight movement on the interstate system and arterial roadways, as well as to regional rail yards and waterways. The problem with this interchange is that it was built more than 50 years ago and hasn't had a major rehabilitation since this initial construction. Again, you all can imagine the volume of traffic and the things that have changed from the time this interchange was built in the 50s and 60s to what it experiences today. So we have high traffic volumes out here, single lane ramps with tight curves that make the interchange prone to congestion, which causes it to operate under breakdown conditions for most of the day, or meaning gridlock most of the day. The American Transportation Research Institute and the Federal Highway Administration have indicated that this is the slowest, most congested highway freight bottleneck in the nation. We have about 400,000 vehicles a day go through this interchange, and on average we have about 1,000 reported crashes a year. So it has some issues. Here is an aerial view showing the interchange before this project began. So on this view, we're looking to the west. This, for those that are familiar with Chicago, this would be UIC, University of Illinois Chicago's, the northeast corner of their campus would be right in here, I guess. And then it would be 290 heading out to the west, Congress Parkway behind us and the post office, and then I-90-94 running north and south. Here is an aerial rendering showing what this interchange is going to look like after the project is completed. The purpose of the improvements that we're making at this particular site include improving the safety and mobility, improving the bridges, roadway, and drainage systems, doing this while minimizing environmental impacts, and it's also to enhance community connectivity on the local street network. Some of the key project features, including expanding to 4 lanes on I-90-94, expanding to new 2-lane ramps for what we call ramp EN and ramp NW. Ramp EN stands for east to north. Ramp northwest, east to north. Ramp NW is north to west. Key project features also include reconstructing several of the crossroad bridges, or the structures that are carrying various streets across the interstate system. So these include like Morgan Street and Peoria Street that are crossing I-290, Taylor Street, Harrison Street, Van Buren Street, Jackson Street, Adams Street, Monroe Street, all of those that are crossing I-90-94, as well as redoing a whole bunch of other bridges and ramps in the heart of the interchange, and building some big flyovers that I just showed you a minute ago. The total estimated cost for this particular project is around $680 million, so it's a big project. This number includes all of the engineering, both the preliminary engineering and the construction engineering. It includes all of the land acquisition cost, all of the actual construction cost. We build in contingencies because we know there are going to be changes, etc. So that's kind of our total estimate for the project. And this particular project is broken into 35 separate construction contracts. So remember when I said before, the way we do this is we have a letting, we advertise contracts on the letting, and then contractors bid on those contracts, and then we select the low bid contractors. On this particular project has 35 separate individual contracts that will be let for people to bid on. We started letting projects in August of 2013, and we will continue to do so, I believe, through September of 2020 is what our current targets are to get all of these 35 projects let. The overall completion of this project, if everything stays on task, we expect to be done out here around November the 30th or 1st of December in 2022. So we've got a lot of work left to do. We've got a lot done, but we have a lot left coming. The status of where we are today is that 16 of the contracts are substantially complete, or we've got most of the work done. That's about $250 million of the 680 we've got done. We have 8 contracts currently under construction, total value of work of around $160 million. And we have 11 contracts that are remaining to be let, or about $270 million. As I said just a minute ago, we're going to be letting projects all the way up through 2020, so we don't have all of the design done yet. The design for this project is about 70% done, and then the construction is about 60 to 70% complete. People that are good with math would add this up and say, well, I'm only seeing about 60% of the dollars spent. This percent complete gets a little subjective because we pay attention to how quickly different work items get done. When we're putting it out there. So we pay attention to percent complete based on dollars, percent complete based on time, and then percent complete based on the residents, that important person that I was talking about just a minute ago, their feel for where these contracts really are. How close do they think we are close to getting done? Like maybe we've got a lot of dollars left to spend, but we're going to hit some high production activity and we're going to blow through them in a hurry. That's why this gets a little. You have to watch this kind of with a grain of salt. So to help you understand the substantially completed construction, or what we've done so far, this slide demonstrates that we've built Taylor Street over I-90-94. We have the north to west flyover bridge complete. We have completed Harrison Street over I-90-94. We've completed Halstead Street, Peoria Street, and Morgan Street. Halstead Street, I'll show a photo of it being completed a little bit later, and you can see where while we don't normally build vertical type construction, we typically stick with horizontal construction. So I mean, by horizontal, I mean roads and bridges and retaining walls are vertical, but retaining walls, roads, and bridges are what we typically build. Every now and then we do get called to do things outside the norm. So like that Halstead Street, it has a canopy on top of that bridge for the CTA. And then on Peoria Street, when I show you that here in a little bit, Peoria Street it's a large structure, but it's actually just a pedestrian structure. And as part of that contract, we actually, it included building a new CTA station for people to board the CTA. The ongoing construction includes the westbound I-290 main line. It includes a Jackson Boulevard utility relocation, ramp NE. So remember I said NE, they did a good job in the design standpoint of naming all of these ramps. So ramp NE stands for the ramp that's going from the north to the east. That's how they numbered them. Sometimes you'll get into projects and they'll call it ramp J or ramp H, and it doesn't mean a lot to you in the real world. You think, well, where is ramp H at? But on this project, it's pretty easy to follow. The ongoing construction also includes some water main relocation and rehabilitation. It includes the reconstruction of the Van Buren Street Bridge, the reconstruction of the Monroe Street Bridge, as well as the reconstruction of the eastbound I-290 Congress Parkway bridges and the eastbound I-290 mainline reconstruction. Here we see where some of this major ongoing construction work is located. Again, this is what we're working on right now. So we have the eastbound and westbound I-290 main line. We have some water main relocation and retaining wall work down in this area. We have this ramp north to the east that we're working on. We have the eastbound I-290 bridges in here, as well as, actually down here, that includes the rehabilitations that we're doing to some of the Congress Avenue bridges. Congress Avenue turns into I-290 for those who have been in downtown Chicago or are familiar with this. We're also working on Van Buren Street over I-90-94. We have some utility work going on at Jackson Boulevard, and then we're working on the Monroe Street structure over I-90-94. Some of the major upcoming work includes ramp EN, or ramp from east to north, as well as what we call the interchange ramp completion contract. There's a lot of work in this particular contract. Both of these first two bullet points that I show you up here, you'll note that we've got them advertised right now, and they're on our November 9th letting. That's our next letting, is November 9th of this year. So these two projects are actually on that letting, and will quickly be changing from upcoming construction work to ongoing construction work. We also have the Congress Parkway / Ida B. Wells Drive Viaduct painting coming up. We have the northbound I-90-94, southbound I-90-94, some interchange high mass lighting and ITS work we have to do, and then we'll construct the Adams Street over I-90-94 and Jackson Street over I-90-94, and also we'll wrap things up with some green space, landscaping, and some minor aesthetic type things. Work that is expected to be let here in November. Just a minute ago I said this interchange ramp contracts has a lot of work in them. This gives you an example of all of the different work that's going to be included in those two contracts. So we have some ramp work, some exit works, a lot of retaining wall work. It's going to continue to be a very busy area in the near future. Following construction of the east-west portion, when we get the I-290 and Congress Parkway work done, we're then going to switch over to the north-south reconstruction of I-90-94. This will also include the Jackson Street bridges and the Jackson and Adams Street crossover bridges. and we're targeting again to start some of this work in around 2020. And again, the overall completion of the project is scheduled for December of 2022. Some of the expected benefits once this project is complete includes improved safety, includes reducing congestion and delays, and also reducing environmental impacts. So remember when I started this, I talked about how this interchange is at gridlock most of the day. It has about 1,000 crashes a year that are reported. Those are the things that we're hoping to fix with this improvement when we get all said and done. It won't be perfect because we still have a lot of traffic up there, but it will be better than it was. So here we see some of the work that we're actually doing. So this gives you kind of a scale of construction activities that we're talking about. This is looking south, down I-90-94. So we'll have Congress Parkway over here. We'll have, and then I-290 heading out to the west. You can see if you look close in this photo, we've got a lot of construction stuff going on everywhere in this intersection. You see lots of cranes, you see lots of construction materials, you see a bridge deck over, or a bridge over here that's being built but doesn't have the deck on it yet. This is one of the big flyovers that we've already finished. This is the Hall Street structure that I just mentioned a little bit ago. That's Halstead Street structure that I mentioned a little bit ago. We just finished with the canopy, the CTA canopy that comes over the top of it. And again, here's the University of Illinois Chicago's campus. It kind of helps you get your bearings of what you're looking at here. We have a lot of different construction types out here. Typically, whenever we're building a bridge, we have our beams. Those beams might be concrete, they might be precast, pre-stressed, they might be precast, pre-stressed concrete, or they might be steel. They might be rolled steel beams, they might be plate girders. And then on top of those beams, we put, our normal construction is a cast in place reinforced concrete deck that the cars drive on. On this particular structure, you can see if you look close at this photo that we're using full depth precast deck panels. So the way this works essentially is these the precast concrete deck comes out, we lift it into place and set it on the steel girders. In this case is what this particular bridge is using. And after we got everything set in place, they used what's called ultra high performance concrete to lock the panels together, and then to also lock the panels to the actual steel beams. When we got all of that done, we put a concrete overlay on top of the structure. I believe what was called a latex concrete overlay, I believe is what we put on it. But this Peoria Street is a big pedestrian bridge, essentially is what it is. That provides access from the south side of I-290 to the north side of I-290. Due to limited right-of-way and tight work zones, we have a lot of temporary soil retention systems that we have to have out here whenever we're doing our building, because we have a lot of deep construction going on. So we have these temporary soil retention systems to protect the infrastructure or protect the excavations, and then to reduce settlement of adjacent structures that are around it. The typical temporary soil retention system, so a temporary soil retention system, what I'm referring to is all of this steel sheeting material that you see here, or the slide rail system. These temporary soil retention systems are commonly designed by the contractor who is responsible for the contract, and then we check and approve those to make sure the department's interests are being protected, or that we don't have any concerns with their construction techniques damaging either our permanent construction or some existing construction that's out there adjacent to them that could, nothing's going to get damaged, as well as making sure it's safe, because we typically keep this, we're building in the middle of traffic, so we have to make sure that we're not doing anything to jeopardize the life, health, and safety of the traveling public with our construction activities. What you actually see here, if you look closely, you'll see a gentleman, down at the bottom, to give you kind of a feel for just how big all of this stuff is. And you see their jacking machine, or their boring machine, and then you see the casing being jacked. This is actually installing a 72-inch diameter casing, or a 6-foot diameter casing, to run a water line through that's underneath our roadway. So a lot of big stuff. Here we see an actual boring head. We saw that boring machine on the other side. Here we see a boring head where it's daylighting after it's came underneath the roadway. This particular bore was an 84-inch storm sewer installation that was being worked on. So that would be 7 feet roughly. I mean, we're talking really big construction sometimes that we get involved with. Most of the bridges that we're building out here are utilizing drilled shaft foundations. In Illinois, we have 2 types of deep foundations that we commonly build. They're either driven steel piling, or drilled shafts. Not to confuse the issue, we did have some micropile foundations, which are considered a deep foundation on some of the structures up here. But our bread and butter, our normal stuff, is either going to be drilled shafts or driven piling. We typically use a lot more driven piling, like H piles or metal shell piles, than we do drilled shafts. But all of them have their purpose. The typical shallow foundation that we would build would be like a spread footing. We don't build a lot of those. When we're building spread footings, it's either because we've got really good soils up top with no scour potential, like from a stream or anything to wash away those soils underneath our support, or we have rock really close to the surface. More often than not, though, our bridges are supported on deep foundations because the soils at the surface aren't strong enough to support the loads that we're putting on it. So we go down deep to find that capacity, and we do that again with drill shafts or metal shell piles. For all of these contracts up here, I said the foundation of choice for most of this stuff are drilled shafts. We're doing that, 1, because we have big loads, but 2, because we're in a highly urbanized area with a lot of building structures very close to us, so we have to be concerned with vibrations and damaging other people's properties with our construction activities. So the drilled shafts help us to eliminate or reduce those vibrations. Again, with these poor soils, at some point you have to transition from these ramps to pavement that's on grade, which normally involves an approach that's going up. Your ramp has to get a lot of clearance above the roadway that it's crossing, so you've got to start going up. What we're commonly doing out here for these ramp structures is we're building what's called mechanically stabilized earth retaining walls, or MSE walls, and to transition from at grade up to get up on top of the bridge abutments and then continue across the ramp over top of the roadways that you're crossing. Again, the soils are poor, so a lot of what they've had to do in a lot of locations out here is install what's called stone columns to improve the in situ soils that are up close to the surface so that they can handle the weight of this MSE wall that we're building. They're a big mass of fill material. It has a lot of weight. We don't want to have a lot of settlement. Whenever we build these, unfortunately, we don't have the luxury of piling a bunch of dirt on it and letting the soils consolidate and settle for a year or 2 years or whatever, and then come back with our construction. So we'll do, like in this particular cases, we're building stone columns to improve that ground so that we'll get rid of that soil, reduce the consolidation that's going to happen, and protect the pavement that we're building on top of it so they don't crack from a lot of settlements. In addition to using the stone columns, we are backfilling some of these MSE walls with lightweight cellular concrete. The normal way that you would construct an MSE wall would be, as you're putting up your precast panels to make this bin, you'd fill it up with fine aggregate, either sand or either crushed or mechanical fine aggregate. That material typically weighs somewhere in the ballpark of 110 pounds per cubic foot. This lightweight cellular fill that we're using out here weighs somewhere in the ballpark of 30 or 40 pounds per cubic foot. So it's a lot lighter. We're reducing the amount of load that we're putting on the soil up top. Therefore, we don't have our these ground improvements that we're doing with our stone columns and stuff don't have to be. It can be more economical by reducing the amount of weight that we're putting on them. For those who haven't seen MSE walls, this would be an example of a completed MSE wall out here. So again, down here is where you would have your approach roadway, that pavement on grade that's coming up to get on the bridge. If you could see underneath here in this dark area, you would start to see our beams for the superstructure that's taken off. This would be the abutment, if you will, that's on, like, say, drilled shaft foundations. And inside of this, all of it is all of that reinforced soil mass. That's why we call them mechanically stabilized earth retaining walls. So the reinforced mass in this case is a lot of lightweight cellular fill that's supported on stone column ground, and on the ground that's improved with stone columns. We also have a lot of retaining walls that we're building out here. This is an example here in this particular photo. You can see a retaining wall that's being built, and notice the proximity of this wall to the actual buildings. It's very, very tight construction, and again, that's what we have to be careful that we don't damage other people's property as part of our construction activities. We have to use our due care. Here we see those retaining walls where we're putting in ground anchors, or also commonly referred to as tiebacks. We put tiebacks on these types of walls because a soldier pile wall commonly allows for a lot of horizontal deflection. But because we don't want to have a lot of horizontal deflection in these particular cases with these building structures up top, but we have to account for all of the surcharge load coming from these buildings. So we're installing these tiebacks. Normally, since if you can visualize a slender wall that wants to deflect from the load you're putting behind it, normally when you put tiebacks on a wall and stuff, you want to run them horizontal or near horizontal to handle the horizontal forces that's happening. In cases like this, we have very limited right-of-way, and because we have these buildings close to us, we can't send our tiebacks or our ground anchors off of our right-of-way. So in this case, if you look closely, you'll see where they're installing these ground anchors at about 9 to 15 degrees from vertical, which isn't the most economical solution. That in a perfect world you wouldn't do this, but whenever you're constrained by your right-of-way limits and you can't buy more right-of-way, you got to do what you got to do. So through the design process, they look through and find what is the most economically appropriate wall type, and they would have looked at: do we build a T-type retaining wall? Do we build a counterfort retaining wall? A soldier pile wall? What's the most economical type? Soldier piles are the ones that won out here. Here we see some photos that are showing curved girder erections. So this is a girder that's being lifted into place. If you look closely, you can see this curvature with it. This particular work is being done over high volume expressway lanes, so we have to close some lanes when we're doing this. We have to move through this erection very expeditiously so that we minimize the impact to the traveling public. We have to do it safely. So you can see for this particular sequence, the contractor's using shoring towers to help support these girders once they get them lifted up into place. The way this process works for erection is our specs require contractors to have an Illinois structural engineer design or develop an erection plan for these types of beams. Then they submit that to the department reviews and approves it to make sure everything's going to happen safely. Curved girders can be extremely problematic, more so than straight girders, because you can imagine, depending on the amount of curvature that the girder has, the center of mass of the girder shifts out of the line. Say if you drew a cord from one end to the other, the center of mass of that girder gets outside of that cord. So if you just try to set that girder up on two supports, just by the laws of physics or the laws of gravity, it wants to fall over on its own. You don't really get that stability until you get a couple girders bolted together. So all of that has to get detailed and worked out in the erection plan, and then we have to make sure the contractors are following that erection plan, using the right cranes, bolting the right numbers of girders together, all of that type of stuff, so that we're doing our work safely. We're not jeopardizing the life, health, and safety of the traveling public, but that we're also protecting the quality of work that we're doing. So we know what we're building is in accordance with the contract specifications. Here is some photos of some completed bridges. Remember, I talked about the stuff that we have substantially complete or done. This is a photo showing the completed Morgan Street structure over I-290. Here's some photos of that Peoria Street pedestrian structure with the CTA station that I talked about, our Chicago Transit Authority station. So here, the photo on the lower photo is standing on Peoria Street looking at the entrance to the CTA station. So the actual structure, the bridge, as well as the CTA station were all new. This particular photo is taken from I-290 looking back up at Peoria Street. So this is the entrance where you're seeing here. It's down here on this end coming into this station. This is just showing the station as a whole on what got built out here. Here is a photo of the Taylor Street Bridge that's over the I-90-94 that was recently completed. And here is the Halstead Street Bridge and the CTA station canopy that's over top of I-290. This is the canopy that I talked about. If you remember one of those earlier photos that I showed you, that's where you're at here. All right, so hopefully that gives you a good feel for what we actually build in construction. When I say construction, what we actually do, we get these projects built that design has delivered to us. The last thing that I'd like to touch on here this afternoon is the department's ongoing e-construction initiative, so that you can see some of the system improvements or some of the process improvements that we're making with regards to the use of technology. So the department desires to utilize technology that will drastically reduce the use of inefficient paper processes, expedite communications and decision making while we're administering these contracts, enable the efficient retrieval and usage of contract administration data in ways that is not currently feasible, and then provide cost savings to the department. We don't want to use new technologies just because it's cool and it's fun to use. We want to do it because it's a more efficient thing to do and ultimately results in savings to the department. Helps us get what we do done quicker and more economically. And when I talk about here, this enable efficient retrieval of information and usage of contract administration data in ways not currently feasible, what I'm really referring to is, one, it helps, we can share this data during the contract administration process, but then now if we can capture this data in the right way, we can share it with other stakeholders. Remember when I talked about the Office of Planning and Programming, and then like bureaus of operations? We can give this data or make this data available efficiently for other people to use whenever we're operating the system, maintaining the system, and then figuring out how to rehabilitate it in the future. Believe it or not, we struggle with that right now. So the major components of our e-construction initiative is, one, to implement a web-based contract management process, and two, to increase the use of electronic design data to facilitate construction and field verification of what we've actually built. The web-based contract management process, or what we're developing there, will facilitate this paperless contract administration or near paperless contract administration that we desire to move towards. It will enable for the electronic submission of construction documentation by all stakeholders, and then it will enable electronic approvals and then expedite our decision making. So when I talk about stakeholders, the stakeholders on our construction projects might include, or obviously will include the department, obviously will include our contractors who are building it for us. It'll include the Federal Highway Administration whenever federal funds are involved in the construction that we're building. And if it's a local agency project that was on our letting that we're administering or that we have some oversight over, it'll include the local agencies. So there's a lot of different stakeholders involved here. The web-based contract management system that we're developing will provide secure digital management of the construction data, and then it will allow distribution of this construction data to all project stakeholders through internet-connected devices, like iPads, laptops, phones. It'll supposed to work. It'll work on all platforms. So you probably think this doesn't seem new to us or earth-shattering, but let me paint the picture of where we're at right now. So our existing contract management consists of a contract record system, a materials record that we call that I-Cores within the department, a materials record system that we call Mystic, and then a contract payment management system that we call BCM. The construction record system, or I-Cores, is built on a Microsoft Access platform, and it truly is a disconnected, installed on individual laptops, so a resident engineer on one contract doesn't have any connectivity with a resident engineer on another contract. It's all localized. The materials record system was developed in the 1970s. It's a mainframe database that was developed using COBOL. So earlier, I asked for the people in this room, how many of y'all were born in the 90s? And I got just a couple hands. The 70s is probably me. I was 72. So this has been around a long time. And The third system that I'm getting at here with this is our contract payment management system. This system was developed in 1992. It's also a mainframe system that was developed with COBOL. So, I was surprised to learn when you get with the department and you deal with some of these old systems. I'm not exaggerating when I would say there will be some data that you want, and so you know what you want, it's in the system. You'll ask for it, and the answer that you get is, okay, we'll run a report. It'll run overnight, and you can have it tomorrow. That's not really desirable with today's technology. That's why we're moving to these web-based systems to improve this communication, to improve this decision making, to save money off of the ways that we currently do. The disconnected systems that they've served their purpose, and they continue to serve their purpose, but they really force us to be reliant on these heavy paper-driven processes. So it's also worth noting that right now, the way this works a lot of times, depending on the data that's being captured, many times it's somebody capturing it on a piece of paper in the field, and then they have to give that piece of paper to either keep it themselves or give it to somebody else that's back in the office to then key the information into a system if it's data that we actually have to collect. We're a smaller department now. We're never going back to what we used to be as far as the number of employees that we had. We can't afford to do processes like that anymore. So this new system will allow people to collect the data electronically in the field and have it. No more of this redundant or re-entry of stuff where you have multiple people doing the same task. So we currently have, to fix this with our web-based contract management solution or system, we have a project underway that we're calling the Construction and Materials Management Solution. Our CMMS. CMMS is going to replace the existing construction record system, the existing materials record system, and the contract payment management system with a web-based connected solution that will help us collect the information while we're administering the contracts, and then disseminate this information both during administration of the contract and then in the future to other users as we continue with other aspects of the department when it gets into asset management and operating and maintaining what we've actually built. So the replacement of the existing construction record system, the existing materials record system, and the contract payment management solution won't fix everything, but that's the vast amount of data that we have to collect very inefficiently whenever we're administering construction contracts. So this will be a huge step in streamlining our processes. And it's a big part of our reconstruction initiative. So what we've done to date so far is in October of 2017, or roughly the 1st of November 2017, about a year ago, we executed a contract with a company named Exavision. Exavision is based out of Utah. They're a software company. The states that use Exavision software already include Illinois. It includes Iowa, Nevada, New Hampshire, Wyoming, and Texas. From an Illinois standpoint, when I say we use it, we have electronic bidding. So when contractors are bidding to do work on our letting, they give us their bids electronically. Exavision has been providing us with a solution to do that for a few years now. So this will be the next step. Is when we're using them, this will be the contract administration portion of it. So currently, again, we currently use what's known as the electronic bidding subsystem of what they call IPD Web. In the future, or here in the near future, we're going to start using the construction management subsystem and the materials management subsystem. This contract payment management subsystem is all new. It's currently getting developed. Exavision's solution is written in Microsoft.NET with SQL Server databases, and then all of this data will be stored in the Microsoft Azure cloud. In the event that a job site does not have internet connectivity, because believe me, it still happens out there, while most of the state is covered with cellular connectivity that can get you on the internet, we have places where you can't get cell reception. This new system will have an app that will allow people our users to collect certain information in the field, like diary information and quantity placement information, and then whenever they regain internet connectivity, it will automatically sync up and upload this data into the system, so we won't have to have this double entry or have something where somebody's writing the data on a form and then typing it in later. We're working through that process. Moving off of the web-based contract management to the next major component of our e-construction initiative is again that increased use of electronic design data to facilitate construction and field verification. Specifically, the electronic data that I'm referring to is CAD data, and more specifically, the CAD data I'm referring to is like 3D model data that we've started to develop during our design to hand off to us. In May of 2018, the department released a new computer-aided design, drafting, modeling, and deliverables manual. This manual is on our website. And part of what's in this manual is it covers what design should hand off to construction to help us conduct our construction activities more efficiently than we've been able to in the past. An example of what I'm talking about would be the 3D model technology's ability to enable automated machine control or automated machine guidance. This technology has the ability to improve our construction process because it allows us to get construction to grade quicker. So obviously this results in a faster completion of construction contracts, reduced equipment idle time, reduced fuel consumption, and less greenhouse gas emissions. These technologies also reduce the amount of construction staking and restaking that's required. This frees up our limited staff resources to work on other important tasks. We want to use this technology, again, not because it's neat, but because it improves our processes and makes us more efficient. We have to move away from processes that require redundant re-entry of information or redundant activities like staking a job and then turning around and staking it again in the future and then coming back a third time to measure up what's actually been built. So a challenge to the department and our partners, and I guess I would look at a lot of the people in this room as you embark on your careers, will be paying attention to this technology, looking for how technology can make our lives easier. It would be great if we ultimately at some point can find ways to couple these three-dimensional models, this CAD data that we're getting, with our other contract management data. Accomplishing this could potentially allow us to eliminate duplication of efforts associated with documenting construction, developing as-built plans, and developing a database of assets. As an example of this, it could be to collect the data from machine-grade control technology, use this data to generate daily as-built models and daily inspection reports and quantity records, and then ultimately pay estimates for partially completed work. Linking model information to a construction record system could allow us to associate material certifications to the three-dimensional models as well as GIS databases. Being able to efficiently determine locations where a specific material has been used could prove very beneficial in our endeavor to design, build, and operate and maintain a world-class transportation system. So that's all I have for you with this talk. I would like to give some acknowledgments. People that helped me with the slides or with a lot of information that's contained in this presentation. That is Brian Katab from our IDOT District 1 Design Office. Eric Ray is one of our resident engineers in District 1, and then Ryan Sheely is one of our project review engineers that's in the Central Bureau of Construction. So with that, I'll take as many questions as you all have.
Does anyone have any questions for Justin?
Yes, ma'am.
To get the pizza?
Yeah.
Oh, you want to get pizza? Okay, we can take you can take a 5-minute break or whatever and go get your.
Continue with the QA in the room.
Sure.
Do that.
Thank you.
I'm sure people around you right now.
Your pizza's probably cold if you didn't eat already. What's that?
Take your pizza too, let's make it.
No, I'm good. Don't worry about it. I'm sure. You go ahead and eat those. No, you don't. You can eat.
If you don't eat, I won't eat.
You got it.
It was a very, very good presentation.
Well, thank you.
Maybe I'll start with the question. since I'm not eating. But it's really interesting to hear that since 1990s, no increase in the infrastructure budget. That's what you mentioned.
No significant
No
increase.
significant increase. And I know that there's even sometimes a decline because of the crisis that we were having in Illinois because of the budget issues.
Yes.
And you mentioned about some additional funding resources. What are these additional funding resources do you think can be a solution in Illinois?
All right, well, let me recap first so that everybody's on the same page with when I talked about our funding levels. They do vary from year to year. We are a pay-as-you-go state for the most part. We do have some bonding programs, but we try to live within our means with the department. So we try to make sure whenever we let a contract that we have the funding available to pay for that work. So depending on, and we pay attention to contract payout. We're not, depending on the size of the contract, like this particular project that I highlighted here that has 35 contracts in it, some of those are one construction season contracts, some of those are 2 or 3 three construction season contracts. So we pay attention to the payout and we develop the size of our program. Depending on revenues that are coming in, when I say it's like roughly historically maybe $2 billion a year, that fluctuates. It might get down to $1 billion a year in some of our forecasts, or $1.5 billion, somewhere in those ballpark. Our funding for our program comes primarily from fuel taxes, motor fuel taxes, not the sales taxes on fuel, but just the motor fuel taxes. So this funding comes from the federal government. From the federal government, we get about 18 cents a gallon on the gas that you pay. When you buy gas at the pump, and it's $3 a gallon or $2.70. Out of that price, 18 cents is a federal motor fuel tax. Diesel is like 24 cents, 23 or 24 cents, but for gasoline it's 18 cents. That rate was set in 1993 and hasn't changed since. I hope I'm telling you right. In the 90s. I don't want to. I keep notes in my phone, but and then we have the state motor fuel tax. The state motor fuel tax is 19 cents a gallon, and the diesel tax is like the diesel addition or whatever they call it on top. It puts it up to around 23 or 24 cents a gallon as well. But again, that state tax was increased from 13 cents a gallon to 19 cents a gallon in 93. And so in 2000, in roughly the 2000s, we had an Illinois First program where part of that took some motor vehicle registration fees and gave the department a bigger portion of that motor vehicle registration to use on our infrastructure. But when it did that, it also shifted some of the motor fuel tax that we were historically using for the state's program over to the local program. So in general, but you can see that our funding sources have been what they are since around 93. So as people buy cars that are more fuel efficient, that's great and it's an environmentally responsible thing to do. From our perspective, well, I'm not saying don't buy fuel efficient cars, but I'm saying it's not a percentage. As gas prices go up, some people think they're getting more money because it's a percentage, the price is high. It's not. It's flat and fixed fees that we get. So whether gas is $4 a gallon, $6 a gallon, $1 a gallon, what we get for it is the same. We get a 19 cents or 18 cents combined together, 30-something cents maybe total on every gallon that's sold. And when I say 30-something cents, that all varies as well because the federal government develops their highway program, and just because there's say 18 cents a gallon on federal motor fuel tax for gas sold in Illinois, that doesn't mean you're going to get it all back. Some states are winners, some states are losers. In the past, depending on highway bills, Illinois has been a donor state, I guess you would say. For every dollar collected in Illinois, we've gotten 93 cents back or something like that. On the flip side, some states are very good recipients. And we have a system like that because if you're traveling from here to California, whenever you get into Kansas or other states, or if you drive through Montana or Wyoming, lower population states, you still need to use those roads. We still need to have an interstate system that's all connected. So it is what it is. Even though some states may not collect a lot of revenue, you still have to make sure that we have a complete network so you can get from point A to point B. The overall, right now, Illinois is doing pretty well. I mean, we get back a little bit more than we give, so we're not a donor state with the current highway program. But again, that's kind of dodging the point of the funding levels haven't changed since the 90s, and they're just not high enough to sustain this forever. Regarding the types of revenue sources, I don't know what the right answer is. There's a lot of groups working on it. One of them is called the Transportation for Illinois Coalition, or TFIC. And you can go to their website, see some information, or you'll hear them talking at a lot of presentations. Some of them, the common solutions are one, increasing the gas tax, trying to take this 19 cents that we get and increase it up. Others are called looking at a vehicle mileage-based system that you pay, depending on the amount of miles you drive, you pay more. That seems fair, but you know, I don't know what the right answer is, and I don't know what will win out. But everything has pros and cons. It's a tough decision. All I guess I would say is we'll take whatever we can get. We need people outside of the transportation industry, or we need people besides our engineers and our contractors saying we need more transportation funding, because admittedly it's self-serving. I mean, I'm a guy that works for the Department of Transportation saying I need more of your money, you know. We need people, we need our users of our systems to say, yeah, you know, we don't like having posted bridges or closed bridges. We don't like having rough roads, and that will help us get to the solution ultimately, you know, and less self-serving, I guess I would say. Yes, sir. Or yes, ma'am, you had a question before you had to get some pizza.
I was able to get a pizza, so thank you. Thank you for the really nice presentation. I was curious with the initiative with the e-construction, how does that get implemented with the other districts?
So how are we implementing the e-construction initiative with other districts? For example, with the contract administration, or the CMMS solution that we're developing, we've formed a team of about a group of, say, 40 core people from statewide, from all 9 districts. All of our 9 districts are involved, as well as our central office. That team was involved with selecting the vendor, Exhibition, that we have working on this for us. That team met after we selected Exhibition. We brought the 40 people together with Exhibition, had a meeting, and we kind of went through what we call a gap analysis. So Exhibition has a solution we call CMMS, Construction and Materials Management Solution. They call it IPD Web. And so they come to us, we go through all of the requirements that we had in our request for proposals that we said we needed, and we made sure that we were on the same page with Exhibition as far as this is what we're actually looking for. This is what this requirement means. And we looked for gaps, things that they already had, things that they didn't have, and that they were going to, or pieces of the puzzle they were going to have to develop and give to us. So all of these 40 people from across the state participated in these gap meetings with Exhibition. After we got done with that, Exhibition has gone back and started configuring and developing their system. I say configuring and developing. What we call these are like COTS systems, customized off the shelf. Nobody makes a solution like turnkey that we could just start using. Astro has a product called Astroware. It's an Astroware project is what it's called now. They were one of the vendors that put in for us. We didn't end up picking that one. We had about 8 people put in saying that they could give us some type of customized off-the-shelf solution. So with that, since nobody can give you a turnkey solution, you try to use as much as what they already have. You try to mold your processes to theirs, and in places where you can't, they have to develop functionality that you actually need. So after we had our gap meetings with all of these people, Exhibition has went back and started developing small pieces of this puzzle, or small pieces of their system for us, and getting it configured right. After that, we took those 40 people and we broke out like a smaller group of it that includes a lot of the district representation as well as central office, and we're testing these little pieces that Exhibition has given us. You know, we don't need 40 people all testing the same thing and all finding the same bug or the same functionality that's not working. So we have a small group of people that's testing pieces of the puzzle as Exhibition gives them to us. Once we get enough pieces put together, we're gonna do a release. We're gonna have 4 releases for this particular. When we roll out this CMMS, we call them epics. So hopefully we don't have an epic failure. I tell people, I don't know who picks these names, like, oh, epic, no one picked epic. But Epic 1 is supposed to come out here in February of 17. Once we get enough pieces of Epic 1 put together, and the small group of testers say, you know, we think this functionality is working, we think it's good, we'll roll it out to the core team, that configuration team of 40 people, and we'll let them do some testing on it and look for things that might have been missed. When we know they're good with it, we're then going to pilot the system on some select contracts to just make sure that it actually is working. And then once we know that it's working, we'll roll it out to the masses and start using it on all of our contracts. prior to doing that, we'll have to train all of the districts on this, the people who haven't been involved with this core team. We'll have to train all of them on how to use it and what it does. And so we'll have basically a train the trainer type concept where the exhibition will help train key department staff or expert power users, whatever you want to call them, and then those power users will be responsible. We'll have power users in all the districts, and they'll be responsible for training and answering questions to the users as we start rolling this out. We also have to bring in the locals into this. It's the local public agencies at some point, because this system will be used by. It'll be used to administer any contract that's included on our list, whether it's a state-let state project or a state-let local project. So, does that help? Yes, sir.
I have a quick, thanks for the presentation.
Sure.
So I was wondering, so electrified vehicles are traveling, electrified trucks are coming. So you listed all these funding sources, and most of them were based on the fuel percent per fuel. So how the IDA is trying to collect tax or funding from these electrified vehicles if they don't buy any fuel? Or like what are the plans?
So, is your question, what are we going to do if the fuel use, if we start using electric vehicles and stuff that aren't buying fuel?
Yeah.
What are we going to do?
Yes, that's it.
Yeah,
And they're already in use.
Yes.
They're already using it. They're traveling on the highways. They're traveling on the bridges. So how? So do they travel for free?
I'm glad you're seeing the problem. In that, yes, I mean, right now we get some funding from motor vehicle registrations, like your license plates and stuff, that go into our program. The big elephant in the room is our motor fuel tax. So while we'll get some, because you have to license these vehicles, as more and more electric vehicles use the roads, they continue, if you see Tesla's truck now, it's going to haul 80,000 pounds. That electric 80,000 pound truck will be doing the same damage to our infrastructure as a 80,000 pound diesel truck. The diesel truck will be paying for that damage, if you will, or paying to use our system. The electric truck will not. So ultimately, when I talk about funding sources and stuff, we're going to have to find a new way to fund. And this isn't just an Illinois thing. This is a national issue. That we're going to have to find new ways to fund our transportation system. And that's the problem. When you increase the gas tax, that's great, but 19% of zero is still zero. So. Yes.
You talked about integration of 3D design that into construction and translating that into pavement and asphalt. With that at CMMS, are you looking at revamping methods of measurement that are currently out there to include a more robust definition or use of electronic devices?
Yeah, so he's asking if we're embracing this technology, are we going to update our procedures to legitimize, make it legitimate to use, say, a robotic total station to measure up areas or volumes that you constructed, instead of what we call right now when we do earthwork, the normal practice is to use what's called average end areas. So you take a cross section at what we call a station or a point through the roadway, and we say what's the area of that cross section between what the existing ground line was and what the new ground line was. Then we go 100 feet away and we take another cross section and we look at that area between the new ground line and the existing ground line. We average those two end areas together. Say this area was 100 square yards. This area was 300 square yards. So the average is what, 200 square yards, and we multiply it by that 100 foot length and come with a volume. That's not a real accurate way to do it. That's what we've done forever. That's what our specs. That's how our specs say we compute quantum. To answer your question, yes, we are working to. We have some specs now that allow electronic tools to be used for measuring, and districts are doing that. But in my opinion, our existing specs are still too focused on the technology that's being used. What we want to try to do is come up with some specs, and we're working on coming up with some specs that focus more on the accuracy of the measurement that's needed and less on how you get it. So, if we need X for areas, we may need, stuff to the 10th of a square foot or something of that nature, and then for vertical or for volumes, to the cubic yard. So we'll focus more on the accuracy, and that'll be that. Because right now, like robotic total stations and stuff are spot on with X, Y, and Z. GPS units are spot on pretty much with XY. That's right, but you're vertical, it's not. So we just needed to, it's not that we don't want to tell people you can't use a GPS unit, because maybe there are base stations involved that's improving the vertical accuracy of the GPS unit to within a suitable level to use it that way. So that's why we want to focus more on what accuracy is needed and less on what technology you're going to be using. Yes?
My question is, thank you first for the presentation.
You're welcome.
My question is related to, you were talking about storing the data online, like there will be like a database to store data. So I was wondering what IDOT is doing to have like to cyber secure this data.
We're trusting execution. No, this question is, what are we doing to make sure this data is secure? To be truthful, a lot of our data, right, a lot of the data that we're collecting right now, like if I was to go on my computer, I have what's called a P drive and an S drive and an O drive and a C drive. The C drive is the only drive that's on that computer. All the other drives are on servers. Right now, they're state-owned servers that are ran by another department within the state government called the Department of Information Technology, or DOIT. It used to be CMS, now it's called DOIT. But we're moving away from that. I mean, you run the risk of your state systems getting hacked the same way that you run the risk of private sector type systems. You follow me? So whether we're storing on the state server or we're storing it on a public sector server, right now that the state is good with that. We just I'm a civil engineer and a structural engineer. I just have to rely on the IT people to make sure they're doing their due diligence to keep that data secure so that it doesn't get deleted. And we are a little more nervous too, as we move into this new realm. We have to have ways to operate if for some reason something bad happens and the internet goes down, or in an area the internet goes down, or whatever. We still have to continue our construction operations. People don't want to hear when you're sitting in traffic in a backup in a construction zone and no work's going on. Nobody wants to hear there's no work going on because the internet's down, right? We're going to have to keep working. So we will have to have processes in place that allow us to work offline. A lot of times it might involve, I think what it will involve is maintaining a lot of the forms that we have right now, like either in Excel spreadsheets or PDF forms, and hopefully at some point in the future, with a future enhancement, maybe some type of what they call APIs or something can be developed so that if somebody fills something out on a form, we have some efficient way to get that data into the system and things get up and running and re-secure to begin.
But other than like the data being removed, are the data public? So is it fine?
No. So his question was, is the data actually public? Most of it will not be public. Most of it will only be accessible to a user with the appropriate credentials. So when I say that, not every user needs to be able to do every function that the system will do. For example, a inspector will need to enter quantities of work placed, will need to enter comments about that work. They don't need to post that work to a pay estimate. So while they'll have credentials to input certain information, they won't have credentials to input all information, nor will they have credentials to view all information. And it'll be the same thing like with contractors. Contractors will be giving us information. They'll be able to see the information they give us. Whenever we issue a pay estimate, contractors will be able to see their pay estimate to know what we're doing, the quantities we're recording. But if you were the contractor, you'd be able to see what I've said you've done. But if he was a contractor, you would not be able to see the contract that he's working on. So the system that we're developing, when it gets into the actual users of it, we can control, or we're told we can control who can see what data by user, as well as who can see what contracts. And then whenever we get done with this data, Exhibition will be housing it for future use. Some of this data we probably will make available to the public if there's data that should be made available, that they have a use for. We have a lot of data that we make available to the public right now when it comes to like vehicle traffic, the amount of traffic on our roadways and different things of that nature. Other data will only be available to, say, department personnel, but it'll be much more accessible than it is today. Like right now, our current processes with a lot of this data that we collect a lot of it on paper. We retain this data for 3 years, and then through records disposal, a lot of it we just dispose of. So we call job boxes. When we have volumes and volumes of paper of just data that we've collected, we keep for that certain amount of time frame, and then we dispose of it. In the future, we won't need as much physical storage space, so we'll probably keep some of the data longer than we have in the past. In my opinion, we ought to keep data for as long as the life of the infrastructure is out there. Some of them we do, like when we drive piles, if a bridge is going to last 100 years, we'll keep that piling data for 100 years. Or other stuff that doesn't matter, like tickets. I brought 10 tons of asphalt or 20 tons of asphalt on this particular truck. We don't need to keep that information very long. We won't keep that information very long. Yes?
Just out of curiosity, when you have a mega project like this, what are the categories or what are the considerations to separate it to 3,500? Is that based on expertise, parallel timeline? And then also, how does that influence the letting process? Since you have 35 from one project.
They try to bring stuff to letting. They pay. There's a lot of things that go into that. They try to pay attention to the size of the contract, how much work is going to be in any given contract, spread it out, if you will, so we can have lots of contractors working instead of one contractor responsible for everything. So we pay attention to dollar thresholds. We pay attention to what makes sense to our users of the system. Doesn't do us any good to get a portion of the work done, but you still can't use the system because you don't have something else done. So sometimes that, if you're doing roadway and a bridge, sometimes we'll have a roadway contract and a bridge contract. Sometimes we'll lump them together. But it really gets into dollars, and so we pay attention to the size of contractors and what makes sense, what are logical termini from one contract to another. And then as far as what lettings they go on, that gets back into our planning and programming people who are telling us how much money we have to spend, how they're going to pay out, and we pay attention to that. And in the state of Illinois, we have our fiscal year starts on July 1st of any given year, and then runs through June 30th of the following year. So we let things accordingly. We let only what we can pay for. If that makes sense. So that balances out some of that as well.
Okay, with that, let's think just